Good morning to Sir Zailan and our fellow friends. Today we are going to present the principle of work and energy. So now let's get it started. So we from the group 5 are comprised of 5 members, which is SHENG, Chong Horng, LUQMANUL Hakim bin SABLI, Muhammad AMIRUL bin MOHD FAUZI, and HAZRUL bin HAMDAN.
Now, it's my turn to present about the introduction of our topic. Principle of work and energy is the change in kinetic energy of a body is equivalent to the net work done on the body. Principle of work and energy is a concept that provides the basis for solving a variety of kinetics problems. Generally, this method is called the energy method or the principle of work and energy, and it can be boiled down to the idea that the work done to a body will be equal to the change in energy of that body. The principle of work and energy examines the energy of a rigid body at two different states of positions and the work done on the body to the move between those two states. Typically, the work done by conservative forces work we can reverse perfectly with no losses. Conservative force equal to energy is conserved when work is reversed is presented as potential energy instead. Dividing energy into kinetic and potential energy pieces as we often do in dynamics problems. We arrive at the following base equation for the principle of work and energy. The equation is initial kinetic energy plus work done 1 minus work done 2 equal to final kinetic energy. The second equation is total initial kinetic energy plus work done 1 minus 2 equal to total final kinetic energy. It is important to notice that unlike Newton's second law, the above equation is not a vector equation. It doesn't need to be broken down into components, which can simplify the process. However, we only have a single equation and therefore can only solve for a single unknown, which can limit the method.
So for the basic theory, by incorporating the equation of motion, sum of Ft equal to ma, t equal to mv dv per ds. The principle of work and energy can be written down as T1 minus sum of U1 minus 2 equal to T2. The work done by all the force acting on the particle as it moves from position 1 to point 2 is referred as U1 minus 2. Work is a scalar that can be positive or negative. The kinetic energy of the particle is starting and final position respectively are T1 and T2. T1 equal to 0.5 m minus multiplies with V1 multiplies with 2, and T2 equal to 0.5 m multiplied with V22 are the results. Because velocity is squared, kinetic energy is always a positive scalar. As a result, the particle's final kinetic energy equals the sum of the particle's initial kinetic energy plus the work done by all force acting on it as it moves from its starting to final position. It's important to note that the work energy principle T1 minus U1 minus 2 equal to T2. It's not a vector equation. A scalar value is assigned to each phrase. The unit of kinetic energy and work are the same energy. The SI system use the joule as the unit of energy, with 1 joule equaling to 1 Newton meter. The units for FPS system are FTLB because this force produce no work. The principle of work and energy cannot be utilized to determine force direct normal to the path in general by adding the kinetic energy of all particles in the system and the work owing to all forces operating on the system. The work and energy principle may be applied to a system of particles. The work and kinetic energy principle, also known as the work energy principle, asserts that the work done by all forces acting on particle equals the change in a particle kinetic energy. The work energy principle is derived.
So for question 5, when S equal to 0.6 meter, the spring is not stretched or compressed, and the 10 kg block, which is subjected to a force of 100 Newton, has a speed of 5 meter per second down the smooth plane. Find the distance S when the block stops. So there is work done by three different forces. The first force is U equals to 100 bracket S2 minus 0.6, and the second is work of the block which after some calculation is 49.05 multiply S2 minus 0.6 bracket n, and the third one is work of the spring force which we will get after some calculation is minus 100 multiply bracket S2 minus 0.6 bracket squared. Now we will apply the principle of work and energy here, and we will get 0.5 multiply 10 plus 100 multiply bracket S2 minus 0.6 bracket n plus 49.05 multiply S2 minus 0.6 minus 100 bracket S2 minus 0.6 bracket n squared equals 0. And we will multiply and add up them, and we will find S2 minus 0.6 equals to negative 2.09 meter, and S2 will become 2.69 meter.
Now I'll be presenting the part result and solution. For question 1, a boy with a mass of 48 kg rides a skateboard with a mass of 3 kg on a horizontal road. At the top of an incline, his velocity is 1.30 meter per second. He rides down the incline and reaches the bottom with a velocity of 3.4 meter per second. The difference in height between the top and the bottom of the incline is 0.540 meter. Calculate the average resistive force while the boy rode down the incline. So we use the formula of the principle of work and energy. Initial kinetic energy plus work done equal to final kinetic energy. 0.5 mU square plus mgh equal to 0.5 mv square plus E. Then we use 0.5 times 51 times 1.30 square plus 51 times 9.81 times 0.54 equal to 0.5 times 51 times 3.4 square plus E. Then E will be equal to 18.4824 joule. Then we use the formula E equal to Fd. Then we can get D is equal to 38 meter. Then we use F equal to 18.4824 divided by 38, and the force will be 0.486 Newton. For question 2, a block of mass m with 3 kg is released from rest at the top of a frictionless ramp. When the block reaches the bottom of the ramp, it slides onto a belt moving to right at constant speed, Vb equal to 6 meter per second. Let μk and μs denote the coefficients of kinetic and static friction between the block and the belt. Find the distance traveled. Given that h equal to 2 meter, coefficient of friction equal to 0.075, and Vb is equal to 7 meter per second. To solve this question, we use the formula of principle of work energy. T1 plus U1 to 2 equal to T2. Work done is, since it starts from rest, mgh equal to 1 over 2 mvq square, and vq is equal to 2gh square root. Note that vq is smaller than vb when mgh is smaller than 1 over 2 mvb square. At conveyor belt, the work done is equal to Tr minus Tq, and the work done only refers to the friction. We use the formula F equal to ma. n minus mg is equal to 0. So n is equal to mg, n equal to 8 times 9.81, and the normal force is equal to 78.48 Newton. For the friction, we use the formula mu k times normal force. So 0.075 times 78.48 is equal to 5.886 Newton. Then mu k mg times d is equal to 1 over 2 mvb squared minus 1 over 2 mvq squared. Mu k mg times d is equal to 1 over 2 mvb squared, and 1 over mvq squared is equal to mgh. Then we divide the mass. Mu kg times d is equal to 1 over 2 vp squared minus gh. Then d is equal to 1 over 2 vb squared minus gh divided by mu kg. Then we sub the component inside. D is equal to 1 over 2 times 7 squared minus 9.81 times 2 divided by 0.075 times 9.81, and the distance is equal to 6.63 meter. For question 3, given 2-pound brick slides down a smooth roof with VA equal to 5 feet per second, find the speed at B, the distance D from the wall to where the brick strikes the ground, and its speed at C. We also use the formula of principle of work energy, TA plus UA to B is equal to TB. 1 over 2 times 2 divided by 32.2 times 5 squared plus 2 times 15 is equal to 1 over 2 times 2 divided by 32.2 times VB squared. And we can get VB is equal to 31.48 feet per second. Then we apply the principle of work and energy again. TA plus UA to C is equal to TC. 1 over 2 times 2 over 32.2 times 5 squared plus 2 times 45 equal to 1 over 2 times 2 over 32.2 times VC squared. And VC will be equal to 54.1 feet per second.
So now for question 4, given a 0.5 kilogram of ball of negligible size is fired up a vertical track of radius 1.5 meter using a spring plunger with K equal 500 Newton per meter. The plunger keeps the spring compressed 0.08 meter when S equal to 2 meter. Find the distance as the plunger must be pulled back and released so the ball will begin to leave the track n equals 0 when theta equals to 135 degrees. So we will use the centripetal acceleration here, and we will do F equal mass multiplies centripetal acceleration. And we will get W cos 45 degrees equal to mass multiply V square divided by radius. Now we will further do it, and 0 and we will get 0.5 multiply 9.81 multiply cos 45 equal to 0.5 divided by 1.5 multiply V square. Then after some calculation, we will get V equal to 3.2257 meter per second. So we will use the principle of work and energy next and substitute the value. And T1 is 0.5 meter multiply V1 squared minus work done Y minus bracket 0.5 K S2 squared minus 0.5 K S1 squared bracket N equals to 0.5 meter ms multiply mass multiply V2 squared, and we will get S1 equal to S plus 0.08 meter and S2 equal to 0.08 meter. So we will calculate Y. For Y, we will get 1.5 plus 1.5 sin 45 equal to 2.5607 meter, and finally we will get 0.0 0 minus 0.5 multiply 9.81 multiply 2.5607 minus bracket 0.5 multiply 500 multiply 0.08 square minus 0.5 multiply 500 multiply s plus 0 bracket s plus 0.08 bracket n squared and bracket n equals to 0.5 multiply 0.5 multiply 32.2257 squared, and we will get s equal to the final distance is equal to 0.179 meter or 179 millimeter. Alright, so now we thanks LUQMAN for the basic theory. Now I will derive the principle of work and energy formula. So to derive this formula, we must use the Newton's second law, which is F equal ma. And F is the force, m is the mass, and a is the acceleration. So since acceleration is the rate of change of velocity, it can be expressed as F equal mass multiply rate of change of velocity. So we will break down it further. Now F equal to m multiply the derivative of velocity with respect to displacement multiply uh, this rate of change of displacement, since the derivative of velocity with respect to displacement multiply rate of change of displacement is equal to dv dt. Now we will integrate both sides with displacement and we will get integrate force with respect to displacement and equal to integrate mass with multiply rate of change of displacement with respect to velocity. So we will insert the initial position and the final position which is coded as 1 and 2. We will get the 2 per 1 uh, integrate force with respect to displacement equal to integrate mass multiply velocity with respect to velocity. So after integration, we will get the total work done equal to 1 per 2 mv square in final position minus 1 per 2 mv square initial position 2. Now since t equal 1 per 2 mv square, we will get uh, total work done equal to final kinetic energy minus initial kinetic energy, or initial kinetic energy plus total work done equals to final kinetic energy, which is our final answer.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya HAZRUL HAMDAN dan saya akan membincangkan mengenai perbincangan kajian. Pertama sekali, penyertaan masalah dan proses kajian kuantitatif dinyatakan bagi isu yang dibincangkan. Yang kedua, komponen penting dalam metodologi akan dibincangkan dengan terperinci dalam isu berikutnya. Hal ini kerana ia merangkumi perbincangan tentang permasalahan kajian. Pergaulan tanpa batasan melalui media sosial menjadi masalah dalam kalangan masyarakat dan inisiatif yang boleh diambil bagi membendung pergaulan tanpa batasan dan kesimpulan bab ini. Yang ketiga, isu-isu tertentu telah dibangkitkan oleh penyataan masalah kajian di bawah topik penyalahgunaan media sosial. Di samping itu, pemilihan kaedah kajian secara soal sendiri adalah paling sesuai untuk mengutip data kuantitatif, di mana soalan berbentuk objektif dan subjektif disertakan bagi mendapatkan jawapan dan pandangan berbeza daripada responden. Akhir sekali, akibat dari kebolehan limitasi pengkaji mengenai topik penyalahgunaan media sosial, kaedah soal sedik melalui platform online untuk mendapatkan perkongsian secara langsung daripada responden. Itu sahaja daripada saya. Terima kasih.
In conclusion, we have solved all questions that related in our topic, which is principle of work and energy. We identified all the problems in each question and solved it to get the correct answer. Therefore, the formula is the most important thing to calculate every question in this report. In our research, we got two basic formulas for this topic. The formulas are T1 plus total U1 minus 2 equal to T2, and total T1 plus total U1 minus 2 equal to total T2. The first formula states that the particle's initial kinetic energy plus the work done by all the forces acting on the particle as it moves from its initial to its final position is equal to the particle's final kinetic energy. And the second formula is being extended to include a system of particles isolated within an enclosed region of space. Lastly, this topic also very important for humans to use in every single day, especially for the engineers in designing and solving the equation to complete their work. I think that's all from us. Thank you.